Today we're going to talk about translating words into symbols. And we're going to focus on mathematical expressions. So this is chapter 1.8 in your book. And our goal is to take some phrase in English and translate it to a numerical expression. Translate it to a mathematical expression, because we might also have variables in that expression. So many phrases can lead to the same expression, right? We have many different ways of expressing the same concept, and we don't all write and speak the same way. So many phrases can lead to the same expression. For example, I could have the phrase, the sum of a number n and 50. So I've got my phrase over here and my expression over here. The sum of a number n and 50, well, that's just going to be n plus 50. Now I could have had the phrase, a number n increased by 50. That's again n plus 50, right? I'm increasing n by 50. I could have also had the phrase, the total number of n and 50, or the total of a number n and 50. Could have also been this. Total of a number n and 50 is still n plus 50. Or I could have just said a number n plus 50. That's still the n plus 50. Okay? So many different phrases can lead to the same expression. Now, the reason why we're even talking about translating words into symbols is that it's important for communication, right? So often real life problems come to us through written or spoken word, right? They don't come to us as equations or expressions that we just solve. In order to solve the problem, which is coming to us through written or spoken word, we need to be able to translate those words into equations and expressions that we can then solve. Okay? So let's take a look at an example. And here we want to write the mathematical expression for each phrase. So the first phrase that we'll look at is the difference when 4 is subtracted from 72. Okay. Well, we're taking a difference, and that difference is between 72 and 4, and 4 is being subtracted from. So that's going to be 72 minus 4. And I'll box my answer. Okay. The next phrase that we'll look at is the product of 15 and a number y. Well, when we talk about product of numbers, that means that we're going to multiply those numbers. So the product of 15 and y is going to be 15 multiplied with y, which is going to be 15y. So the next phrase is going to be 17 times the quantity 94 plus 12. So when we talk about quantity of something, that means that those things get grouped together, right? So the quantity 94 plus 12 is going to be something that will group with a grouping symbol, right? Remember that grouping symbols can be parentheses, they can be square brackets, and they can be curly braces. Okay, so we're going to group 94 plus 12 with parentheses, and then we're going to multiply that with 17, right? We know to do that because it says 17 times the quantity 94 plus 12. And I'm going to box my answer. So the last phrase that we'll take a look at is 2 less than the quotient when m is divided by 9. So quotient tells me that I'm going to do division. So m divided by 9 that quotient is going to be m over 9. Okay? And then I'm going to take 2 less than that. So I'm just going to take my quotient, m over 9, minus 2 to get 2 less than the quotient when m is divided by 9. Okay, so mathematical expressions often represent real-life situations. So a lot of the examples that we're going to go through or the problems that we're going to solve today are real-world situations, right? The first one that we're going to take a look at is related to age. So Anne is n years old right now. And again, we're going to write the variable expressions for each phrase. So the first phrase that we're going to take a look at is Anne's age 5 years from now. So we're talking about in the future, what is Anne's age going to be? And how far in the future are we going? Well, we're going 5 years into the future. So Anne's age right now is n. Anne's age in 5 years is going to be n plus 5. 4 years, so the next phrase that we're going to look at is 4 years less than half Anne's present age. So we have this, half Anne's present age, which is going to be n over 2. And then it's 4 years less than that, so n over 2 minus 4, right? When we talk about something less than something in a phrase, usually there's going to be some subtraction happening. Okay, the next phrase that we'll take a look at is twice Anne's age three years ago. So Anne's age 3 years ago is going to be Anne's age now minus 3. And then we want to do twice that, so that's going to be 2 times n minus 3. And the last phrase that we're going to look at for Anne is David's age if the sum of Anne and David's age is 30. So we already have that Anne's age is n, right? We could say that David's age is d. And we know that the sum of their ages together is going to be this 30. So that tells us that, remember that this little arrow means, implies, although really this arrow should be coming from this sum. But anyways, so what we know is n plus d equals 30. And what we're trying to do is express David's age. So David's age is represented by the d, so d is going to be 30 minus n. And that's the answer. Okay, let's do another example. Again, we're going to be writing the variable expressions. For the given phrases. So the first phrase is going to be the number of months in y years. Well, let's say that y was 1. We just want the number of months in 1 year. We know that's going to be 12, right? There are 12 months in a year. let's say that we were looking at y is a half. Well, the number of months in half a year, that's going to be 6. Y is 2. The number of months in 2 years is going to be twice as many as the number of months in 1 year. It's going to be 24 months, right? So each year contributes 12 months. So to get the number of months in y years, we just multiply y with 12. Right? Because, you know, it's for every year that we have in y, it's going to be 12 months, right? So it'd be like y of these 12s, so to speak. Okay. Let's do the next phrase. The total value in cents of D dimes and Q quarters. So we're looking for total value. That tells me that we want the sum, right? Total value is another language for sum. Okay, and I want it in terms of cents, and I've got D dimes. Well, every dime is 10 cents. So that means that I've got 10 D, right? D is my number of dimes, and that is the number of cents that the dimes contribute. Every quarter is 25 cents, which means I've got 25Q. 25 times the number of cents tells me, 25 times the number of quarters tells me how many cents I have from the quarters. And then, because I wanted the total value, I just add these two together to get 10D plus 25Q. And that gives me the total number of cents that I have. Okay, so now we're going to go through some of the exercises in your book. And the first couple of exercises are going to come from the oral exercises. So if we look at number 17, and again, we're taking phrases and translating them to mathematical expressions. So the first phrase that we'll look at from the oral exercises is number 17. If x is a positive integer, and remember that another way of writing that is x in z plus, right? Z is integer, and that little plus there means I want just the positive integers. So if x is a positive integer, the next greater positive integer is what? Well, if I think about what this means, I've got some number line here, and somewhere on this number line is going to be x. It could really be anywhere on, you know, this part of the number line, right? From 1 onwards, I could have a value for x that's valid, right? X could be 1, x could be 4, x could be 7, or any integer in between, or any integer greater than this, right? It's a positive integer. So if I look at x as 1, and then I want to get the next greater positive integer, I just go to my next integer that's greater than the one I'm at, and now I went 1 unit, so I'm at x plus 1. If x had been 5, in order to get the next greater positive integer, I would again go 1 unit down the number line, and now I'm at 6, which is x plus 1. So that tells me that my answer is x plus 1. Okay, let's do another example. We're going to do number 18. So now y is a positive integer and y is odd. So I have y as some odd positive integer, and I want to identify the next greater positive odd integer. Is what? Well, again, I can take a look at my number line. Okay, here I'm a little more restricted in terms of what my variable y could be, but y could be 1, for example, right? That's a positive odd integer. Y could be 3, 5, 7. So let's just say that, for example, y is 1. Now if I want to get to my next positive odd integer, I'm going to go 2 units down the number line, and I'm sitting at y plus 2. If y is 5, and I want to go to the next greater positive odd integer, I'm again going to go 2 units down the number line and sit at y plus 2. Okay? So my next greater positive odd integer is going to be y plus 2. Okay? Let's move on to the written exercises. Here, it's asking us to write a variable expression for each word or phrase. So the first one that we're going to take a look at is number 7. Number 7, the phrase is the sum of a number p and 11 multiplied by the difference when 14 is subtracted from a number q. And I'm running out of space here, so what I'm going to try to do is move this to the next page. We'll see if that's possible. Okay, that seems to have worked. So our phrase is the sum of a number p and 11 multiplied by the difference when 14 is subtracted from a number q. And this is quite a mouthful, but the trick is to just break the phrase down into smaller phrases that you can combine at the end, right? So I've got one smaller phrase, which is the sum of a number p and 11. And then I'm going to multiply that with the difference when 14 is subtracted from a number q. Now, if I translate each of these mini phrases, so let me call this the sum of a number p and 11 is going to be phrase 1. The difference when 14 is subtracted from a number q, that's going to be phrase 2. And then phrase 3 is going to be when I combine all of those. So phrase 1 is a number p added to 11, so that's p plus 11. Subphrase 2 is the difference when 14 is subtracted from a number q. So I've got a number q, and I'm subtracting 14 from that. And when I combine these two together, I'm multiplying them. So 3 is going to be p plus 11 quantity, right? That was my number 1, times q minus 14 quantity. And that was my number 2, right? So I've got to picture these as quantities that are getting multiplied. And then I'm going to box my answer. Now, if you'll notice, I often box my answer. And that's because when I'm solving problems, I like to be able to look at the problem and see where the answer is. And so when you box your answer, you can very quickly see where the answer is. Okay, let's do another exercise. Let's take a look at number 9. So the phrase for number 9 is total of a number a and twice a number b divided by total of a number c and the fifth power of a number d. And I can see now that these phrases take up a lot of space. So we're going to again move this to the next page. Okay, and we're going to take the same strategy that we took before, where we break this up into subphrases. So we've got total of a number a and twice a number b. That seems like a subphrase to me. Divided by total of a number c and the fifth power of a number d. So total of a number c and the fifth power of a number d, that's also a subphrase. And then divided by, that's what's linking those phrases together. So I'm going to call total of a number a and twice a number b, that's going to be subphrase 1. Total of a number c and the fifth power of a number d, that's going to be number 2. And then 3 is going to be for my linking. Okay, it's the exact same pattern that we had for the previous example. Now, when I take a look at 1, this itself could have been divided into other phrases, right? Total of a number A and twice a number B is its own little subphrase, right? And a number A, that's its own little thing. And then the linking happens with total, right? Which indicates that I'm adding them together. So I could call this C, and I could call this A and this B, right? So my phrase number 1 is going to be A plus B. It's going to be C, right? Okay, so A was just the number A, and B is twice a number B, so that's 2B. Okay, so my sub-expression number 1 is going to be this A plus 2B. Sub-expression number 2 is going to be total of a number C. I've got a number C and the 5th power of a number D. Total tells me I'm going to sum these, and it's not just going to be C plus D, it's going to be D to the 5th, right? The 5th power of a number D is D to the 5th. So this 5th power of a number D translated to D to the 5th. Okay, and then finally, I'm going to go back and combine these with my number 3, which is going to be 1 divided by 2, right? It's this total of a number A and twice a number B divided by the other total. So 1 divided by 2, that's going to be A plus 2B quantity divided by quantity C plus D to the 5th. And that's my answer. Okay, now we're going to take a look at written exercise number 14. This is asking for number of minutes in S seconds. Okay. Well, usually we talk about how many seconds are in a minute, right? Usually people say, well, you know, we've got 60 seconds in a minute. And now we want to go in the other direction. If I have some number of seconds, might be 60, might not be, how many minutes do I have? Well, let's take a look. So let's say that I have S seconds and I've got, and I want to see how many minutes I have. Well, 1 second is going to be 1/60th of a minute, right? 60 seconds is going to be my 1 minute. 30 seconds will be half a minute. 120 seconds will be 2 minutes. So the expression that, or the equation that 60 seconds in a minute tells us is times S equals my number of minutes. Sorry, I did that wrong. I said that wrong. It's my number of minutes is going to be S divided by 60, right? Or rather, if I have 60 seconds in a minute, for every minute that I have, I've got 60 of those seconds, right? If this is number of minutes, and this is number of seconds. Okay, so this should be my answer, right? Because I'm trying to get the number of minutes in S seconds. Let's just double check that S over 60 matches with the intuition that we had before, right? Now I'm plugging in the values for S in this column into this expression here. And I'm gonna check it with this column over here, which was my intuition, right? So I'm plugging in S as 1 and I get 1 over 60. Now I'm plugging in S as 60 and I indeed get 1. Now I'm plugging in S as 30 and I get 1/2. Now I'm plugging in 120 as S and indeed I get 2. Okay. So S over 60 is my number of minutes. Let's do the next exercise. Now we have the phrase, the product of a positive odd integer, x, and the next greater positive odd integer. Okay, so I know I'm going to do a product, and my product is going to be between this sub-expression and this sub-expression, or sub-phrase, I should say. So the first one is just going to be x, right? We've got some positive odd integer. And then the next greater positive odd integer from x is going to be x plus 2. And then we're taking the product, right? So we're multiplying those. Remember that we spoke earlier with oral exercise number 18 about why the next greater positive odd integer would be x plus 2 if we're looking at the positive odd integer being x. So this is my answer. All right. The next example that we'll do is number 26. So now our phrase is 1/4 your age 20 years from now. If your current age is n. Okay, so you're n years old right now. What is 1/4 your age 20 years from now? So again, this is a bit of a subphrase, right? Your age 20 years from now. That's going to be N is my current age, and 20 years from now I'm going to be 20 years older. And then I want to take 1/4 of that entire quantity, right? So that's going to be 1/4 n plus 20, or 1/4 times the quantity n plus 20. And that's my answer. Okay, the next thing that we're going to do is represent the answer in terms of the given variables. Okay, so we're taking a look at number 29, which says the difference between two numbers is 10. If the lesser number is A, what is the greater number? Okay, so I've got two numbers that I'm subtracting to get to 10, right? Let's say that I'm going to call them x minus y equals 10, because right now I've got my blinders on and I've just looked at this part of the problem. So difference between two numbers, for right now I'm going to call them x and y, is 10. So that's what this expression here says. Now I've got some more information. If the lesser number is A, okay, well, when I subtract two numbers and I end up with a positive number, that tells me that the number I was subtracting was smaller than the number I was subtracting from, right? X minus y equals 10 implies that x is greater than y. That is the only way that we can end up with a positive number when I subtract y from x. So that means that the lesser number, which was y, is actually going to be A. So let me revise this. And now it says, what is the greater number? Well, x is my greater number, and I can move my A over to this side of the equal sign so that I can isolate this x. And when I do that, I get x equals 10 plus A, right? In order to move the A over, started off with x minus A equals 10. If I add A to both sides, I have not changed my equality, so I'm still good there. And now I can just cancel these, and I get the x equals 10 plus A. Okay, and really the problem said nothing about x, so the part that we want to box is actually just this 10 plus A. All right, let's do number 35. So Sam is M years old. Lisa is 3 times as old as Sam. as Sam was 5 years ago, how old is Lisa right now? Okay, so we know that Lisa right now her age is 3 times as old as Sam was 5 years ago. So we've got this subphrase, Sam 5 years ago, which is going to be Sam's current age minus 5. And then we have Lisa's final age as 3 times that, right? So Lisa right now is 3 times m minus 5. Okay, the next example that we'll look at is number 37. So this says that two sides of an isosceles triangle each measure y centimeters. The third side is 5 centimeters longer than the other 2 sides, as in 5 centimeters longer than each of the other 2 sides. And now we want to express the perimeter in terms of these variables, which really we just have the one variable, right? We've got our isosceles triangle here. And remember that an isosceles triangle is defined by 2 sides that are the same length. So in this case, they're both y and y. And this third side is going to be y plus 5. So the perimeter is going to be the sum of all the sides, right? That's going to be y plus 5, or 3y plus 5. And I think that for the purpose of this problem, I don't think that they're expecting you to simplify. So this kind of answer would have been perfectly fine. Okay, the last example problem that we're going to do is number 39. Oops. So here we have a passenger train P that travels at v kilometers per hour. And then we have a freight train F that travels at a speed x kilometers per hour slower. And the question that we have is, how much farther can train P travel in h hours? So we could say, well, how far does train P go in h hours? Train P travels, for every hour, it goes v kilometers. So for h hours, it goes h times v kilometers. train P travels HV kilometers in H hours. Train F travels H times V minus X kilometers in H hours, right? Because train F's speed is going to be V minus X kilometers per hour, right? Because it goes X kilometers per hour slower than train P. So now, when we talk about how much farther train P traveled in H hours, we just need to take the difference between these two, right? H times V minus H times V minus X. And since this isn't asking us to simplify, we could box this answer and say that we're done here. But I just want to take a moment to check our intuition a little bit. So we'll carry it out and see if it matches some intuition. So if I wanted to expand this and simplify, I would use something called the distributive rule, which is I take what's out here and I distribute it out or to each thing in the parentheses, and I multiply. So HV minus HV, that's this thing multiplied together, minus H times negative X, right? Which is going to be HV minus HV. That's going to go to 0. And then I've got minus H times negative X, which is going to be plus HX, right? My final answer would be H times X. So if train F is going at a speed of 5 kilometers per hour slower than train P, that means every hour train F has gone X kilometers less than train P, right? So over the course of H hours, it's going to be this H times X. So, we could have done the math out as we did over here and then simplified, or we could have read the problem and thought, well, train F is going X kilometers less per hour than train P, so after H hours, it's gone H times X fewer kilometers over H hours. Okay, so that's it for the examples. I think that the problems that would be good to work through are actually no oral exercises this time. The written exercises that I think are good to go through are number 8, number 10, number 17, 22, 23, 25, 30, 33, 36, 38, 40, and 41. Okay, that's it for today.